You're in the zone building a project, so you ask your AI coding assistant for a solution. Almost immediately it replies. With a confident, clean code snippet and the standard install command like npm install safe svg validator. As developers, our instinct is to grab that suggestion, paste it into the terminal, and hit enter to keep the momentum going. But this seamless convenience bypasses the standard verification process, setting up a security failure where developer trust is exploited. What you didn't know is that the package you just tried to install never actually existed in the registry when that AI model was trained. Instead, an attacker identified that the model frequently hallucinates this exact name and registered it just hours before you made your request. The moment you hit enter, you triggered a silent script that instantly scanned your local files, extracted your AWS keys and database passwords, and sent them to a remote server.
Security researchers have found that AI models hallucinate the same fictional package names thousands of times across different users. This makes slopsquatting one of the fastest-growing vectors for supply chain attacks. Hackers are no longer waiting for a human to make a typo. They are now explicitly weaponizing the predictable errors of the AI models we use every day. To understand how this works, we have to look at the nature of large language models. They do not query live registries in real time. They predict text tokens based on statistical probability. When asked to solve specific problems, these models frequently hallucinate highly logical but entirely fictional package names by combining common technical keywords. Attackers now use automated scrapers to identify these recurring hallucinations across the internet. They then register these exact names on NPM or PyPI and back them with legitimate-looking GitHub repositories to complete the deception. In this attack model, the hacker never has to spearfish the victim. The AI effectively delivers the target directly into the trap. But how does a malicious package compromise your system if you haven't even imported the code into your project yet? When you run a standard install, npm checks the package file for lifecycle hooks, specifically the post-install script. This script runs automatically. It doesn't need root access or administrative privileges to execute a simple 10-line Node.js file on your machine. The script rapidly searches your local project directory for .env files, .bash history, or your cloud provider credentials. It encodes those secrets into base64 and fires an HTTPS post request to an external webhook. This entire exfiltration takes just 120 milliseconds, leaving behind only the standard green success output in your terminal. Standard developer tools are designed to hide this background execution, making a devastating compromise practically invisible during a routine install. The threat escalates with the rise of autonomous coding agents, tools that have permission to read tasks and execute bash commands without asking for manual confirmation. When an autonomous agent hallucinates a tool and runs the install command itself, the human review gate is bypassed entirely. This ultimately transforms slopsquatting from a deceptive trap into a silent, automatic system compromise with zero human friction. Protecting your local machine and your company's repositories requires a shift in how we handle AI-driven suggestions. Step 1 is to verify publisher provenance. Before running an install, check the registry date. If a package was published 4 days ago with zero maintainer history, it is a high-risk dependency. Step 2 is to disable lifecycle scripts by default. This prevents any third-party package from executing arbitrary code during the installation process. By running this command, you ensure that unvetted dependencies cannot execute silent background payloads on your machine. Step 3 is to restrict autonomous agents. AI agents must never be granted unrestricted shell execution in environments that hold production secrets. Instead, run these autonomous workflows inside isolated Docker containers with no access to your primary secret volumes. These 3 steps reintroduce the critical friction necessary to block automated supply chain attacks. AI coding tools offer a significant boost to development velocity, but that speed cannot replace basic security hygiene. As we integrate these tools deeper into our workflows, we have to adopt a core principle. All AI-suggested dependencies are untrusted user input until manually verified. What security precautions do you currently take before installing new NPM packages? Share your process in the comments and subscribe for more deep dives into back-end systems and modern security. Thanks for watching.